Good day everyone, I am Joey Bonabra of BSFi 2A or VS Fishers 2A, and I will be discussing all about the center of mass, linear momentum, and collision. Now let's talk about the center of mass. The center of mass is the point where the whole mass of the system can be supposed to be concentrated, and motion of the system can be defined in terms of central mass. The center of mass is a position defined relatively to an object or system or of objects. So it is the average position of all parts of the system, weighted according to their masses. Say for example, simple rigid objects with uniform density, the center of mass is located at the centroid. For example, the center of mass of a uniform disk shape would be at its center. Sometimes the example is located at its center where there isn't any material. So as you can see in the figure, there is a circle, square, and rectangle. So the red dot on the center of each figure defines the center of mass. So in getting the center of mass of an object or system, so mass of any object or system is generally the center of mass can be found by vector addition of a single weighted position vectors which point to the center of a mass of each object in a system. One quick technique which let us avoid the center of mass use of vector arithmetic of the components of along each axis. For example, for object of position along the x-axis, we have the formula central of mass sub x is equal to mass sub 1 times x sub 1 or the x-axis plus mass of 2 times x sub 2 plus mass of 3 plus times x sub 3 and so on, all over mass sub 1 plus mass sub 2 plus mass sub 3 and so on. And similarly, the y-axis, the formula is central of mass is equal to mass sub 1 times y sub 1 plus mass sub 2 times y sub 2 plus mass sub 3 plus y sub 3 and so on, all over mass sub 1 plus mass sub 2 plus mass sub 3. So here is the object, as you can see in the figure. It is the x and y axis, wherein it is a system of three flat objects. So as you can see, the location of the center of mass in an x direction is, you have to count from the first square down to the position of the object, wherein it is 1 kilogram, 1 kilogram, and 2 kilogram. 2 squares and 1 circle. So the x-axis of the mass is equal to 1 times 4 plus 1 times 6 plus 2 times 12 all over 1 plus 1 plus 2, which is the mass, is equal to 8.5, the total. And in y direction, 1.5 plus 1.12 plus 2.8.5 all over 1 plus 1 plus 2 is equal to 8.5, the total. Okay. Mass of an object or a system. So in general, the center of mass can be found by vector addition. So it's just like the same, just like we have discussed few minutes ago. So let's move on linear momentum. On linear momentum, it is in scientific definition, it is a consistent with most people intuitive understanding of momentum. A large fast-moving object has greater momentum than a smaller, slower object. Linear momentum is defined as the product of systems mass multiplied by its velocity. So in symbol, linear momentum is expressed in small letter p is equal to small letter m times small letter v, which is the vector or the velocity. Momentum is directly proportional to the object mass and also its velocity. So it is directly proportional once the object is gain height, so gain weight or height, the velocity also increases. So thus, the greater an object mass or the greater its velocity, the greater its momentum. So momentum denoted by small letter p is a vector having the same direction as the velocity denoted by small letter v. So the standard unit for momentum is kilogram times meter per second. So in linear momentum, it is defined as the product of a system's mass multiplied by its velocity. In scientifical, in mathematically explanation or formula, it could be small p is equal to mass over times velocity or m times small v. So example, calculating a momentum. A football player and a football. The first question is calculate the momentum of a 110 kilogram football player running at 8.00 meter per second. Next question is to compare the player's momentum with the momentum of a hard thrown 0.410 kilograms football that has a speed of 25 meter per second. So take note that there is no information is given regarding the direction, and so we cannot calculate only the magnitude of the momentum denoted by small letter p. As usual, a symbol that is italics is a magnitude, whereas one that is italicized boldface and as a narrow is a vector. So in both parts of this example, the magnitude of momentum can be calculated directly from the definition of momentum given in the equation, which becomes p is equal to m times v when only magnitudes are considered. So here is the solution for part 1. To determine the momentum of the player, substitute the known values for the player's mass and the speed into this equation. So the given from the problem, P, the player, is equal to 110 kilograms times 8.00 meter per second. So it will give you a results of 880 kilograms times meter per second. So the solution for part 2, to determine the momentum of the ball, you have to substitute the known values for the ball mass and speed into an equation. So same equation will be used to find the momentum. Okay. The P there is the ball with a weight of 0.410 kilograms and times 25.0 meter per seconds. Excuse me. And this will give you a result of 10.3 kilogram per meter per second. So the ratio of the player's momentum to that of the ball is P player or over the P of the ball is equal to 880 over 10.3 is equal to 85.9. Although the ball has a greater velocity, the player has much greater mass. Thus, the momentum of the player is much greater than the momentum of the football. As you might guess, as a result of the player's motion is only slightly affected if he catches the ball. So we shall quantify what happens in such collisions in terms of momentum in a later sections. So now let's move on to the collision. Alright. Collision. A collision is a short duration interaction between two bodies or more than two bodies simultaneously causing change in motion of bodies involved due to internal forces acted between them during this. So collision involved forces. There is a change in velocity. Take note of that. Then the magnitude of the velocity difference at the impact is called the closing speed. All the collision conserve momentum. What distinguishes different type of collision is whether they also conserve kinetic energy. So collision, the line of impact, it is the line which is a common normal for surfaces are closest or in contact during the impact. This is the line along which internal forces of collision acts during impact, and it is the Newton's coefficients of restitution in defined only along this line. Okay, it's a line of impact. When dealing with an incident body that is nearly parallel to a surface, it is sometimes more useful to refer to the angle between the body and the surface rather than that between the body and the surface normal. In other words, 90 degrees minus the angle of incidence, it is mathematical explanation. So this small angle is called glazing angle. Collision at glazing angle is called glazing collision. So as you can see in the figure, so we have the surface normal with a line, and it is A over B, which is the angle, and the line or the direction. Okay, so in collision there are two types of collision between two bodies. So the first one is the head-on collision or one-dimensional collision, wherein the velocity of each body just before impact is along the line of impact. Yon. Second, non-head-on collision. It is the oblique collision or two-dimensional collision where the velocity of each body just before impact is not along the line of impact. So in head-on collision, the line of impact is also along the body. And the second one, the non-head collision, so each body before the impact is not along the line of impact. So magkataliwas silang dalawa. Next. According to the coefficient of restitution, there are two special cases of any collision as written below. Say, a perfectly elastic collision is defined as one in which there is no loss of kinetic energy in the collision. In reality, in any macroscopic collision between objects will convert some kinetic energy to internal energy and other forms of energy. So no large-scale impacts are perfectly elastic. So if there is a large impact, it is not perfectly elastic. So however, some problems are sufficiently close to perfectly elastic realistic that they can be approximated as such. So in this case, the coefficient of restitution equals 1. So in other words, the next is the inelastic collision. It is one in which part of the kinetic energy is changed to some other form of energy in the collision. So the momentum is conserved in elastic collision as it for elastic collisions. But one cannot track the kinetic energy through the collision since some of it's converted to another forms of energy. So in this case, coefficient of restitution is not equal to 1. And that's all for our report for center of mass, linear momentum, and collision. Once again, good day. Good day. I am Joey Bunaora with my members Mac Jefferson, Cali Tisin, Raymark Putalon, and Trisha May Bonetti. That will be all. Thank you and bye bye.